Okay, so this one is all special products. And for the most part on it, it's going to be just taking the square root of the first one and the square root of the second one because they're going to be repeated, is what they mean by special products. So our v squared, if we were to factor v squared, it'd be v times b. And then factors of 4 that add to get 4 would be 2 and 2, because 4 and 1 would be 5. So, and then since they're both positive, and you can write it like this. This one, special products, so they're both going to have subtract because there's plus sign at the end. Now factors of 9 and 4 that multiply then add to get 12 would be 3 and 2 because we're taking the square root of both sides. So the square root of 9a squared would be 3a. Square root of 4 would be 2. And then if you wanted to check it, you would multiply it out. And you'd have 9a squared subtract 6a subtract 6a plus 4. So on this one, now that I've got you kind of trained, the square root of 49 would be 7x. And the square root of 16 would be 4. They're both plus signs. And we'd have 49x plus 28x plus 28x plus 16. So we can write 7x plus 4 squared. This one, factor out a 3 because we want that. There's not a square root of 3, and since this is the thing over special products, I'm assuming I can just take it from. So we'd have n squared subtract 20n plus 100. Square root of 100 would be 10, and since they're both subtract, and then I could check it 3 times n squared subtract 10n subtract 10 plus 100, and that would be, so our answer would be 3n subtract 10 squared. Okay, 16 and 9, they both have square roots. That's what we're going to do in a minute. These all have x squared with them, so I'm going to factor out that x squared first. So I'd have 16y squared plus 24y plus 9. And then I'd factor out, or I'd take the square root of both sides to get that special product. So I'd have x squared times 4y plus 3 times 4y plus 3, which would give us, if we were multiplying it out, 16y squared plus 12y plus 12. So our answer would be x squared 4y plus 3 squared. All right. We have 25 and 16, so we would have 5x subtract 4y squared. Ooh. This is what we call difference of two squares. These right here, you have to be able to recognize them and say, hey, there's a square root of both of those numbers. So here, we'd have c subtract 6 times c plus 6. That's what the difference of two squares equals. It means they have the different signs because if I multiplied these, I would not have that center number. So let's go ahead and check this. So c times c is c squared. C times 6 would be plus 6c. Negative 6 times c. And negative 6 times 6 would be subtract 36. These two would cancel. 6 subtract 6 is 0. So this would be our answer. If there was a plus sign here, we could do crap. You can't factor that. But if there's a subtract between two squares, it's one with plus, one with subtract. So this one, the square root of 1/4 would be 1/2 subtract 3z, 1/2 plus 3z. Remember, when you're taking the square root of a fraction, square root of the top, square root of the bottom. So square root of 1 is 1, square root of 4 is 2. Factor the following. I mean, I can multiply it, but they said factor it. Seven plus 5, 7, 8, 9, 10, 11, 12. So I'd have y subtract 7 times y subtract 5. Okay, I guess that works. I'll have to check that one and see if it's correct on my screen, but you can multiply it out, combine it, and then refactor it out. It's kind of neat. All right, let's see on this one. I can factor 5 out of both of them, and I'm going to get my calculator. So 125 divided by 5 equals 25. So I have 5, and then I have 25c squared subtract 320 divided by 5 is 64. Square root of 25 is 5. Square root of 64 is 8. There's a subtract here, so I'm going to have 5c subtract 8 times 5c plus 8. Cubes. Whoop, whoop. But I'm going to upload the paper that has this stuff on it as well, and you'll just follow along with this. So I got to remember the signs on it. So we'd have a cubed plus b cubed, and then we have c times I'm going to check that one, but I know this one is a cubed subtract b cubed equals a subtract b times a plus a squared plus ab plus b squared. And these are just formulas that you're going to have to use. So the cubed root of w would be w, and the cubed root of 64 is 4. Then we plug them in, and I got to check this one when we do it. So we have w plus 4 times w squared, subtract 4w, and then b 4 squared would be 16. Let's check that. So we'd have w cubed subtract 4w squared plus 4w squared w cubed subtract 4w squared plus 16w. And then 4 times w squared would be plus 4w squared. 4 times that would be subtract 16w, and 4 times 16 would be 64. And then negative 4 plus 4, positive 16 subtract 16. Oh, this would be it factored out. And there's the little formula that's not wrote on this that I'm going to add on to another page. All right. Then here, our a would be w, and our b would be 5, because the cube root of 125 is 5. So then we'd have w subtract 5 times w squared plus 5w plus 25. And then if we checked it, we'd have w cubed plus 5w squared plus 25w. Negative 5w squared, subtract 25w, subtract 125. Positive, negative, so this would be it. Oh, this will be. So on this one, just remember, and I'll write the formula again, a cubed plus b cubed equals a plus b times a squared subtract ab plus b squared. So a equals w and b equals k. This truly is a foreign language now. So you have w plus k. W squared subtract wk plus k squared. Yay. Now they're just getting mean. Okay. So on this one, we have to factor out a y first, so that we would have y cubed subtract x cubed y cubed. And our a would be y, and our b would be xy. Okay, so we'd have, and we're using the subtract one, so we're using this one. So my a is y, so y subtract xy times y squared subtract xy squared plus x squared y squared times y. That's not right. I feel like I'm speaking a foreign language. We should have factored out all of the y4, and then we would have been left with 1 subtract x cubed. So let's scratch this one. It'll look prettier though. So y to the 4th, we would have 1 subtract x cubed left. So y to the 4th times, and this would be 1 and this would be x. So we'd have 1 subtract x times 1 subtract x plus x squared. All right, down here, 27a cubed b cubed 64a to the 6th. Great. All right, we can factor out an a cubed. So I have a to the 3rd, then I have 27b to the 3rd plus 64a to the 3rd. cube root of this would be 3b. Cube root of this would be 4a. So here we go. A cubed. We would have 3b plus 4a times 3b squared would be 9b squared. Subtract 12ab plus 16a squared. What goes into 24 and 375? No. 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 Three. Why didn't I start? Oh. Alright, so we're factoring a 3 out. So I'd have 8x cubed subtract 125y cubed. And the cube root of this would be 2x. And the cube root of this would be 5y. So I have 3 times 2x subtract 5y times 4x squared plus 10xy plus 25y squared. S squared subtract 6x plus 9. Praise the Lord, we went back to something normal. So we'd have an S and an S. Factors of 9 that add to get 3. Or that add to get 6. 3 plus 3 is 6. Does 8 go into 128? It does. So we're going to factor an 8 out. And that would leave us with 6. We're factoring 8y out. 16x squared subtract 1. That's the difference of 2 squares here. So I'd have 8y times 4x subtract 1 times 4x plus 1. Square root of 36 would be 6, and square root of 121 would be 11. And we change the sign because it's the difference of 2 squares. This one's way too complicated for y'all to be doing, but we're going to do it anyway. So the square root of w to the 4th would be w squared. And the square root of 1096 would be 64. So I have w squared subtract 64, w squared plus 64. Can't do anything with this one. This one keeps going. So I'd have w squared plus 64 times w subtract 8 times w plus 8. Can't do subtract 8 though, because there's not a square root of 8. There's square root of 64 is 8, square root of w squared is w. Ask me questions on this. I know there's a couple of places I botched it, and I don't want to leave y'all that confused. So please ask questions. If you need help, I'm here.